Introducing Bourns IsoMOV Hybrid Protector. It's a fact that transients from any number of sources on AC or DC power circuits can damage today's high-tech power electronics. That's why virtually all applications that connect to a power line require reliable overvoltage protection. The trick today is finding a robust solution to meet an ever-evolving set of size, thermal, and surge protection performance design goals. Engineers typically specify metal oxide varistors, also known as MOVs, for overvoltage protection. But a common downside to these popular solutions is that they are known to degrade over time from exposure to line voltage transients. Now there is a new and better approach to circuit protection. Bourns IsoMOV hybrid overvoltage surge protectors are specifically designed to solve the main failure issues engineers typically experience with their MOV circuit protection designs. Using Bourns' proprietary computer-aided modeling techniques resulted in a breakthrough hybrid device design that offers multiple performance, size, and extended lifespan benefits. With nominal current surge ratings from 3 to 8 kiloamps, IsoMOV protectors offer performance that is usually found in larger traditional MOV devices. This enables designers to select an IsoMOV protector that is smaller than the MOV option. Or, to enhance the protection scheme's surge capability, designers can also choose an IsoMOV protector that is the same size as the traditional MOV. The integration of the MOV and GDT devices is tolerant of AC line voltage swells and also offers low capacitance for use on power line communication applications. While suitable as an upgrade to nearly any MOV-based protection design, the extended temperature range and low leakage are especially well suited to industrial and other harsh environment or exposed applications. With its innovative surge protector design, the Bourns IsoMOV offers the promise of enhanced device reliability and a longer surge protection lifespan in certain harsh environments, which is another excellent example why it is better with Bourns. Welcome to the Bourns Power Transient Voltage Suppressor PTVS Diodes Training Module. The objective of this presentation is to provide an introduction to our PTVS diode products, to compare them to competing technology, to review the selection process, and to look at potential applications. A PTVS diode is a unique protection device designed to absorb high-energy transients such as those from indirect lightning strikes. The symbol for a bidirectional TVS diode is shown, along with the images of some of the available devices. In this training module, we will cover the general characteristics of the products and specifically review the specifications of the Bourns model PTVS3 380C device. We will also cover general applications and how to select the right device for the job. Finally, we will compare the performance of a PTVS diode to that of a competing technology. These are the key terms applicable to defining a PTVS diode. It is important to know the definitions of these terms in order to have a good understanding of how the device works, and to be able to properly interpret the specifications. This drawing is outstanding for explaining and comprehending the general behavior of a bidirectional TVS diode and understanding the terms used. However, it does not describe how a PTVS diode responds under transient conditions. Please note that the drawing is not proportional. The maximum peak pulse current is very large compared to the breakdown current, which is very large compared to the device's leakage current. The plot shows the response of the model PTVS3 380C on a Tektronix 370A curve tracer. Note that the maximum current in the plot is 10 milliamps, which is the current at which the breakdown voltage of the device is specified. The graph on the left shows the model PTVS3 380C diode voltage and current waveforms when subjected to a 3 kiloamp 8 by 20 microsecond surge. The data from the oscilloscope was used to generate the plot on the right. Some data averaging was used to generate a cleaner plot. Note that there appears to be two plots on the current versus voltage graph. This is because the device exhibits a foldback characteristic when the applied surge current is increasing from zero. Compare this to the curve tracer plot on the previous slide. There are many types of transient threats to electronic equipment, including electrostatic discharge, power cross, power surges, and lightning strikes. PTVS diodes are designed to protect electronic equipment against damage from high-energy transients such as those from power surges and lightning strikes. Bourns PTVS diodes are designed to prevent damage to electronic equipment from surges on AC and DC power lines. In a typical application, the device would be connected across the supply lines. There are important parameters to consider when selecting the correct PTVS diode for the job. 1. The repetitive standoff voltage and foldback voltage must both be above the normal operating voltage range of the circuit to be protected. 2. The peak clampdown voltage and breakdown voltage must be below the maximum voltage that the circuit under protection can tolerate without any damage. 3. The peak current rating must be at or above the expected surge current the circuit under protection could be subjected to. And lastly, the capacitance must not adversely affect the normal operation of the circuit, which is generally not a problem on power inputs. The requirements for an AC power line application are listed here. Transients should be referenced to the appropriate industry standard specification. In this application, we will be protecting a 230-volt RMS AC power input against damage from a lightning surge with a maximum peak current of 2500 amps. In order to protect this AC supply, we must not let the input voltage rise above the 600-volt peak. The requirements for this application were pulled from the information supplied and are listed in the table. The specifications of the PTVS-380C are listed in an adjacent column. The requirements match up quite well with the specifications of the PTVS-380C device. However, we still need to check the foldback voltage of the PTVS device to make sure it does not drop below 355 volts. This graph shows the voltage and current waveform response when the model PTVS-380C diode is subjected to a 3 kA 8 by 20 microsecond surge. A line representing the peak input voltage to the power supply has been added to the graph. In order to not interfere with the normal operation of the supply during a transient event, the diode voltage should remain above this line until the diode current returns to zero. Our graph shows that the device meets this requirement. We have now determined that we have selected the correct devices for this application. How do PTVS diodes compare to metal oxide varistors, or MOVs? Let's take a look. We will learn that PTVS diodes provide a much higher level of protection. This chart compares the specifications of the two types of devices. Note that the specifications are very similar except for the clamp voltage at high currents. If we tested each of these devices on a curve tracer, we could expect very similar results for the two devices since the tests would be run at a relatively low current level. The difference between the devices will be seen at very high current levels. At high current levels, the PTVS diode provides a very rigid clamp which limits the peak voltage from the surge to a much lower level than an equivalent MOV. We can see that the voltage across the model PTVS-380C reaches a peak of 500 volts before folding back to a level closer to 400 volts. In contrast, the voltage across the model MOV10D431K rises with the current through the device and reaches a peak value of over 1100 volts. It is clear that the PTVS diode provides a much lower clamp voltage. The graph compares the performance of the model PTVS-380C diode to a single model MOV10D431K MOV, as well as to 6 of these MOVs in parallel. We can see that a current of 2500 amps across the PTVS diode is more than 600 volts lower than the voltage across the MOV device. In fact, even if we use 6 MOVs in parallel, the voltage across the PTVS diode is still more than 300 volts lower. In conclusion, the PTVS diode clearly provides much better protection. Our test results show that an MOV could be used in applications where a much higher peak voltage can be tolerated. In applications that require low clamp voltage levels, a PTVS diode is clearly the component of choice. 4 different current ratings are available: 3 kA, 6 kA, 10 kA, and 15 kA. Multiple working voltage levels are available at each current rating. The tables on this slide show the Bourns devices that are currently available. In summary, Bourns has released a wide selection of bidirectional power transient voltage suppressor (PTVS) diodes to protect electronic equipment against damage from high-energy transients on AC and DC power lines. Bourns PTVS diodes provide reliable and stable clamp voltages for the most demanding surge protection applications. Bourns PTVS diodes are designed to provide protection that meets the requirements of IEC 61000-4-5 up to a peak current of 15,000 amps. Lastly, Bourns high current PTVS diodes are designed to enhance the reliability of your equipment. This product training module introduces the new generation of transient blocking units as the latest circuit protection technology available to the market. We will review the operation of the TBU device, product offerings, target markets, and solutions with a focus on RS-485 port protection as an application example. By the end of the product training module, we hope the reader will have a better understanding of the operation of a TBU device and the use of the TBU device in a typical application providing enhanced circuit protection performance. Bourns delivers the most comprehensive line of circuit protection technology and solutions in the industry. At our engineering centers in Riverside, California, Santa Clara, California, Bedford, UK, and Linkou, Taiwan, we design a full range of overvoltage and overcurrent protection technologies. Bourns offers world-class technology and applications expertise that is the result of many years of circuit protection engineering, design, and support. Bourns' global reputation for extensive application knowledge, quality products, innovative protection strategies, and a wide range of technologies ensures that we can provide the right circuit protection solution for your needs. Depending on the customer's requirements between the cost of low-level circuit protection versus the transient threat level, choosing the right protection level at the design phase can bring significant savings down the line. The basic overvoltage and overcurrent protection scheme used for a typical signal port is shown here. The TBU device is placed in series to block transient currents and provide voltage isolation. OVP2 limits the voltage at the input to the protected circuit and provides a path for transient current until the TBU device is triggered and transitions to the full blocking state. OVP2 may not be required if adequate protection is designed into the protected circuit. After the TBU HSP is triggered, OVP1 limits the voltage across the TBU device to a safe level and also provides a current path for the remainder of the transient event. A GDT should be chosen for OVP1 when used to protect high-speed communication lines such as DSL, Ethernet, or LVDS. An MOV can be used for OVP1 for slower speed applications such as voice or RS-485. The OVP1 device should be chosen so that it does not trigger during power cross tests. The TBU device is a silicon-based solid-state resettable device which is placed in series with a signal path. The TBU device operates in approximately 1 microsecond once line current exceeds the TBU device's trigger current, or I trigger. When operated, the TBU device restricts line current to less than 1 milliamp typically. Operated, the TBU device will block all system voltages and any other voltages including the surge up to rated limits. After the surge, the TBU device resets when the voltage across the TBU device falls to the V reset level. The TBU device will automatically reset on lines which have no DC bias or have DC bias below V reset, such as unpowered signal lines. If the line has a normal DC bias above V reset, the voltage across the TBU device may not fall below V reset after the surge. In such cases, special care needs to be taken to ensure that the TBU device will reset. Otherwise, an automatic or manual power down will be required. The TBU device performance is shown here in Lightning and AC power cross. During the lightning pulse, the blue current line is rising to the trigger point and then blocks the current signal even when the voltage continues to increase. During the AC power cross, the TBU device turns on and off every cycle, and the blue line shows the TBU device triggering in both positive and negative pulses. The impulse speed of the TBU device is shown here, where the reaction time on the green current line shows a limit response of 100 nanoseconds, with a duration of 800 nanoseconds. A key feature of the TBU device here is the low 100 N-joule let-through energy that passes through to the downstream circuitry. This low-energy signal provides opportunities for IC designers to design smaller ICs with lower energy dissipation. The TBU device is typically placed in series between the port and IC. As the Bourns TBU HSP has no connection to ground, the only capacitance added to the signal line is the parasitic capacitance from the device mounting pads to ground. This capacitance can be minimized by eliminating ground plane below the device on the printed circuit board. This minimizes the effect that the TBU HSP will have on the bandwidth of the protected circuit. Here you can see the low insertion loss of the model TBU-CA085-300-WH device in a 50-ohm LVDS test circuit application up to 3 GHz. Bourns has released a new generation of TBU products in 3 product families. For general use applications, the TBU-CA series offers a single bidirectional TBU device with a choice of 5 impulse voltages and 5 trigger currents. The TBU-DT series offers a dual unidirectional TBU device with a choice of 2 impulse voltages and 4 trigger currents. For specific applications, the TBU-PL series offers a dual 50-ohm bidirectional TBU device with a choice of 4 impulse voltages and 2 trigger currents, and an added feature of both voltage and current triggering. Circuit protection is a critical parameter in some markets and applications. The following is a list of applications where a TBU device can offer superior circuit protection. In the telecom market, Bourns' extensive product portfolio offers a complete circuit protection solution to required standards in T1-E1 interface, VDSL, voice, and gigabit Ethernet ports. For the industrial market, the combination of TBU devices with TVS diodes, MOV, or GDT products ensures that high surge protection standards are met, while data transmission rates are also maintained. Here are further industrial application examples showing the combination of TBU devices with TVS diodes and GDT products, ensuring that high surge protection standards are met. In this specific example, we evaluate the advantages and benefits of the TBU device in an RS-485 application. On the left, you can see the traditional RS-485 circuit diagram showing 2 10-ohm resistors and 2 12-volt TVS diodes. While this solution meets RS-485 transmission protocols and fulfills lower-tier protection, the disadvantage for some RS-485 applications with potential surge transients is that the solution does not provide any AC power cross protection, and the 2 10-ohm resistors are not resettable when they are damaged. For the RS-485 application that requires high-energy surge protection, the circuit on the right with TVS, MOV, and TBU devices should be considered. This solution offers resettable AC power cross protection irrespective of surge duration or rate of repetition, has no let-through energy to sensitive downstream chipsets, and provides wide operational bandwidth for high-speed data rates. Here, electrical performance data on the RS-485 solution using TBU high-speed protectors, TVS, and MOV products is shown. Reaction to ESD per IEC 61000-4-2 and surge 1.2 microsecond rise time and 50 microsecond fall time with 5 kilovolt peak voltage are shown on top, while the graphs below show responses to AC power cross under 120 VRMS and 28 VRMS, demonstrating the TBU device operating as expected with lower energy let-through and fast resettability. Support material includes the TBS product datasheets, TBU short-form catalog, TBU product samples for evaluation, and TBU product-specific design kits. Visit www.bourns.com for more details. Bourns Port Notes provides guidance to the designer on the use of the individual Bourns circuit protection products to meet specific standards. In addition, Bourns continues to develop application notes that give detailed information on the use of products. The port notes and application notes are available on the Bourns website and are free to download. To aid the designer in exploring a circuit protection solution, Bourns offers specific TBU product evaluation boards such as RS-485, VDSL, and SLIC protection, which will aid the designer in the performance evaluation. Please contact your local Bourns representative for more details. Bourns has released a new generation of TBU product, offering high-density integrated component technology and enhanced surge protection in small-sized packages for high-speed communication applications. Continuous product development enables Bourns to provide circuit protection solutions for changing market requirements. Bourns circuit protection semiconductor products can bring significant benefits and enhanced performance to your application. Visit www.bourns.com for more details.